Hey, what's going on, guys? Working on this O2 V6 Mustang again. Couple more performance things. I just slapped lowering springs on it. Yesterday, actually, got the alignment done. Really doesn't look like it dropped a whole lot. I mean, it definitely brought it down a little bit. Granted, they're brand new, so they still kind of got to settle in a little bit. Overall, pretty simple install. I went with the Steeda Autosports. I went with their lowering springs, like 1 1/4 drop. But this is, again, only the V6, so if you can get an inch drop, like, you're doing pretty good. I mean, there is a significant weight difference between the GT and the V6. So I wasn't expecting a whole lot, but then I really wasn't aiming for a whole lot either. Being that this is still a daily driver that goes down a pretty crappy freeway, concrete that's all picked up and bubbled, and I shouldn't say bubbled, more like is raised and then drops and then raised and then drops and then raised and then drops on about 3 foot sections, and it's just a constant all the time. So I still needed it to have ride quality. The reviews I saw for these springs, I'm actually rather quite impressed. These actually ride pretty well. I mean, when you hit a nasty bump, there's a bang. I mean, you can definitely feel it. I mean, so the ride quality it's definitely a lot stiffer. Felt a ton better driving around. And I really wasn't able to hit a whole lot of corners last night with it to see just how much, how much better it was biting, which this particular Mustang actually does really well with the cornering, with what few suspension mods I have done to it. It does some pretty crazy things. There's one particular freeway on-ramp where I can fly around the corner in the outside lane, because there's 2 lanes going around the corner, hitting a 90-degree and then shooting on. I can go around that about 50 and never squeal a tire. And I've got in the outside lane, and people on the inside lane are squealing tires going around the corner at 30, 25. And by squealing, I mean tires breaking loose and actually beginning to slide around the corner because they're going too fast for what their suspension system can handle. So I'm rather quite impressed. So I'm excited to see what these are going to do. But again, not really a significant difference in the height. I mean, there's definitely a little bit of noticeable drop. I mean, it definitely looks a lot better stanced, and I really don't feel like it fell a whole lot. That being said, I didn't really put a tape measure on it. Didn't take before and afters. You'd think I'd pay attention to stuff like that, but I was staying late after work. Already had a full day of work. Tore a dash out, reinstalled it, got it all back together, running, AC recharged, cooling system refilled. I mean, it was a process. It was quite the process. So I'm not going to give you how to. I mean, there's hundreds of videos on how to do it on YouTube. One of those I would recommend. I mean, we'll see how the quality of the actually is, as far as cornering and how it handles. And I seem to notice a little bit more body sway, but I felt like the tires were planted a lot better. Yes, I did do an alignment on it. It's a little bit off. They shut the air pressure off on me, so I wasn't able to use the camber caster plates the way they're intended to be used, which is, if you don't know, unload the suspension system when you're making adjustments. So if you're on a rack, you have the access to it. And if you just don't know, I'll show you. So there's your caster camber plates. Now you can do this. You can crack these loose while you're sitting on plates if you're on an alignment rack, and you can use a pry bar to kind of wiggle this. That's the wrong way to do it. Okay, that is the wrong way to do that. The correct way with caster camber plates is actually on these Mustangs is to put one of the jacks on the 4-point hoist, one of the center pneumatic jacks, is to roll it back under the front of the car, expand the arms out, and actually pick it up from the bottom of the control arms. Not the knuckle, not the tire, not the K-member, the actual control arm. And what that will do is it will take the weight off the tire, or so it will allow the tire to basically hang limp, and it will allow the spring to be held in position. if that makes sense. And so basically you're unloading the actual shock or strut. I believe it's just a shock in this, because it's not really a, I mean, yeah, the bolts to the knuckle, but I believe it's still just a shock absorber. But once you do that, when you crack these loose and your caster adjustments, this is just going to float wherever you want it. Literally, so if you're trying to get more camber or less camber, you're just back and forth, and you can sit and watch, you know, like we'll pretend the skateboard's up there or the screen. You can actually, you know, make your adjustments very easily, find where you want to be, and then tighten them back down. And very easy to do. Most, I would imagine you're using a Hunter system, but most alignment machines, there's a selection on the screen that you can actually say, hey, I want to, you know, when you go and you're doing camber caster adjustments, I want to raise, you know, jack up the front of the vehicle to make adjustments. And the computer knows how to compensate for that. So you'll click on it, it'll tell you, hey, go ahead, raise the vehicle, and then click ready. And then you'll click ready. And then once you make your adjustments, you get everything exactly where you want it. Tighten them back down, and then go back to the screen and hit lower vehicle. You'll lower the vehicle. And what it basically will do is once you hit start, it remembers what your camber caster was. So when you make adjustments, it will make those adjustments as if the vehicle is still sitting on the ground. So it sees an additional 2 degrees. It will remember that. And so when you hit back to lower the vehicle, then you actually have to remeasure the camber caster, because it will show where it ended up. You always need to verify that measurement, because I mean there's a lot of variables going on, especially with an alignment, as far as tire pressures, you know, as the vehicle shifted. And the worst case scenario is one of your heads actually shifted, which is I think what happened. We don't have the readily adjustable heads. You got to swap out arms on them, and they're a pain in the butt at the shop, but they function. Anyways, so you'll redo your camber caster swing once you get your final adjustments, and then check, make sure everything's a-okay, and then you're good to go. And that's the easiest way to do it, because once you're loaded, you're not fighting this, because if you were to crack these loose right now and try to make an adjustment, you know, without an alignment rack or do anything like that, which is, I do not recommend. I mean, there's even the smallest little 1/10 of an inch here can be a lot of degrees of camber and caster. It can affect your steering return to zero. So I mean, there's a lot that goes into an alignment. Just kind of a quick, you're doing it wrong, this is the right way to do it on these Mustangs. Most of you probably already knew that, or you know, maybe you've never even done an alignment in your life. I mean, not a big deal at all. Just kind of one of those heads up for you. The main focus of today's video was the GT throttle body. Now I installed this last week. I tried to do a how-to video, showing you guys how to actually what to do, and I ran into issues left, right, and center, to the point where it's basically like, all right, well now I sound like an idiot. So instead of doing that, I did it right, and then now we're coming back and kind of going over what all it takes. So your stock throttle body, which this is the stock, you're going to notice a couple of key differences here. Now, the actual size difference in the video, this looks a lot smaller than this does, but it is a very, very, very minor change as far as throttle body goes. I mean, it's like maybe about the diameter of this ring, one more size up. I mean, it's barely a difference at all. But it does, on my setup, it has made a significant power improvement. No, this has never, to my knowledge, ever been on a dyno. It's hopefully down the road, but I mean, I'm not quite to that point yet where, you know, I can't get the damn thing to keep running with what I've done to it. But basically what you're looking at, so this is off the V6 Mustang. Now, note, if you have not done the Windstar manifold swap, you can't do this. I mean, it can be done. The problem is right here on the back. You see the square port up here at the top? That is your idle air control port, okay? See it down in there, that square hole. So that lets air pass the throttle body, comes back, hits your idle air control valve, which you can see mine mounted up. which actually sits back here on the stock aluminum throttle body. But you cannot swap, because then you have to, I mean, it can be done, but you have to create a custom bracket for your idle air control valve, so that you can still get engine in, and more than likely you just have to build a bracket, something similar to this, which this is still just a real janky setup, but it's sealed, it's holding, it does its damn job. So it's one of those things that's more, at this point, it's just an ugly piece than it is a non-functioning. So eventually that will get upgraded, but that's basically what you need to do. And then run one of your hoses back to your intake, whatever cold air intake or whatever you're running. That's basically what has to happen. I mean, whether or not you've got to do what I did and actually have to tap your intake and then put grommets in and then plastic adapters so you can actually attach your hoses. That's basically what you're looking at. You really might actually end up losing power by doing this. If you don't have any really any mods other than just that GT throttle body or a cold air intake, you might actually lose power. This has had a couple things done to it. Internal motor wise, no, but it does have an MSD Street Fire ignition coil on it. It's got 8mm plug wires, quad fire, Bosch Iridium spark plugs. I mean, there's been some things done to it. So I mean, it's kind of like when you do valves, but you don't do camshafts. Like, yeah, you're going to see maybe 7 horsepower increase, which really isn't a lot for having to pull off your cylinder heads and send them down to a machine shop to have the valves done. 7 horsepower, I mean, that's a lot of stinking work. But you add the camshaft to it, and then you can start seeing 60, 70, 80 horsepower gains. Now, more not likely on a V6, especially a 2-valve pushrod. Come on. But other applications, I mean, you can see some massive improvements. Small block Chevys, small block Fords. I mean, you can actually start seeing pretty decent improvements when you combine certain modifications. So I've got a hotter ignition coil, hotter ignition system, to the point where it can't really get a whole lot hotter without going to a standalone unit. And it really doesn't need it. I mean, that helped with acceleration immensely. So kind of got to have some backup mods for it. As far as tuning wise goes, I've been watching long-term fuel trims, short-term fuel trims, and I'm not really seeing a big difference between the two throttle bodies. So tuning wise, I don't see a whole lot that really should be done. Now there's probably a math calculation between the MAF sensor and the throttle body that I'm not finding. Very likely. I am not an expert. I am a child learning this stuff, basically. I might be technically considered an old man, but I'm still a child as far as that goes. I'm still learning. I'm still, kind of picking it up. But as far as the throttle body goes, on the back of the GT throttle body, there's actually a hole, and they probably call it a Venturi or some crazy weird. But it's on this side that you actually have to fill with a 2-part epoxy, because there's no gasket that can get this to seal to the plastic intake. And the gasket I'm using is the factory Windstar. I mean, you can see I've cut off this is where the old idle air control valve used to be. But I'm using the stock gasket, and it is sealing it just fine. Did a smoke test on it. It's holding up just great. As far as cables, bracket, and your throttle linkage, this will all hook up identical to the stock V6. The only difference is that you actually have to flip the throttle body upside down. I'll actually show you guys that. But let me pull that intake out of there. If you can see, the Mustang is upside down. So all you do is flip the throttle body. The nice thing is you can still reuse your stock throttle position sensor. That is identical. Just make sure when you're installing it that when you install it and bring it back into position, because this is spring loaded, it's not a very heavy spring, but you have to make sure that that blade inside of here lands on the right spot on this sensor. The easiest way to do that is just to slide it in without mounting it, and then turn and then open up your throttle and make sure that you're biting on the right side, because if you miss it, you won't have any throttle position sensor until you get to about 50 or 60% throttle. Usually it will throw a code ECM will throw a code pretty fast for it, but just one of those little things you got to do. The other thing you have to do is you have to mount up some sort of a mount for the overload spring, or for the, I guess that would be a closed throttle spring. I'm sure there's a term for it. But on the GTs, this actually comes back to this bracket here. If you try to do that on this, it will sit and rub. And if you try to go to here, you can actually, when you get under full throttle, that spring would actually bind. Like, I was just sitting here playing with it. I never ran it like this. But that spring would actually pop up over on top and then hold you in a locked open throttle position. So things to be aware of. This can be very dangerous if you screw this up. So kind of pay attention to what you're doing. Make sure you're not going to get any binding. And the way I resolved this was I actually came back on the side stock mount, where they actually mounted the ignition coil on the, I think this was the EGR mount on the Windstar. But I've used this bracket to hold the coil, added an additional bracket to come out to give me a nice clean spring path. And it doesn't give me a whole ton of overload, or throttle return, I should say, or throttle close spring. At least not compared to how far the stock one. But by doing this, I was able to I'm actually able to adjust this. So if I went a little bit tighter or a little looser, and I tried a little bit tighter, and it really seemed to just kind of wear on my leg muscles. Like, I was really kind of fighting it, especially when I couldn't be in a can't have the cruise control set because I've got idiot people all around me that don't know how to use a cruise control. And so anyways, that's another rant about all these people that forgot to drive, how to drive during the coronavirus. But anyways, overload spring, that was kind of took me a minute to figure it out. I was trying to go underneath the intake. And I think I've seen a couple people do that, actually go under the intake and bite. But I really didn't want to try to have another thing to screw with anytime when I have to pull the manifold to do injectors. Like, I'm trying to make this simpler, easier to use, not use forward engineering and complex the hell out of some shit. I mean, I'm trying to make this pretty, user friendly, I guess is what I should say, or repairman friendly. Other thing you got to do is you actually have to, the top of this bracket, you're actually going to have to shave this. That, or, I mean, if you could come up with some type of spacer here, you could definitely do that. But all I ended up doing, this is a there's a word for it. It's a plastic, but it's not a plastic. It's like a polypropylene something. Anyways, don't take a torch to that. Hacksaw, yeah, that'll definitely do it. I actually used a very, very small drill bit, and it actually allowed me to kind of shape it a little bit, mostly due to the limitations of the tools that I have in the garage, which really aren't, not a very big list. Pretty small. But overall, not bad. Pretty simple to do. Still have not seen, the only real thing I've noticed as far as tuning goes, and tuning adjustments, is that my spark timing was already brought up about 3 to 4 degrees, above about 50 to 70 load. I was already brought up about 3 degrees, all the way up to about 5,500 RPM. And with this, it's allowing more air into the engine. I mean, there are other restrictions ahead of you. So, for example, I've got, that's an 80 millimeter throttle body now, or a 76 millimeter throttle body. But this is only like 2-inch pipe. And as it actually comes down and goes in, that MAF sensor is still the stock MAF sensor. So the stock MAF is like 70 or 65 millimeters. It's small. I've got that GT MAF. I think we talked about that in another video. If we haven't, this one should be going in. I've got a filter ordered for this. Really shouldn't be too difficult. I've got the MAF transfer function, so I can actually run that MAF because I can tune it, get it in there. And of course, as soon as I got the GT MAF sensor, my wideband decided to take a crap, so I'm gonna have to order a new wideband sensor, or AFR sensor, whatever you want to call it. But overall, I noticed backing it off, because it seemed to run really well, but it seemed to kind of be at about its, just listening to it, it kind of sounded like it was just a touch just over revved or just a little bit too much spark. So I backed it off a degree and noticed some improvements. I backed it off another degree last night. I have not been able to drive it just to see, especially when it comes to spark timing. I mean, spark, you kind of, as you're adding degrees, it's kind of whatever, and then you get where you're starting to get towards peak power that you can actually achieve or gain from spark. You start rising pretty quickly, where before you're getting 1, 2, 3, 4, 5 horsepower maybe to 12 horsepower or 20 horsepower or 55 horsepower. Depending on your application, you're not going to see that much performance increase out of a naturally aspirated stock V6. You're not going to ever see that. I mean, you'd have to have pretty built motor to see gains like that, or spark timing just be that far out of whack. You're running 0 degrees of spark timing or 2 degrees of spark timing at 5,000 RPM at 60% load with wide open throttle. I apologize, I might have just lost a lot of you there. But then you can see, massive gains if your spark is that far out. But basically I was to the point where I backed it off a degree and I picked up a little bit of power by backing it off a degree of timing, if that makes sense. So timing's coming up, you're getting up to peak power. You get to peak power and then you can add an additional degree of timing and you might not see a difference, or you might actually lose, 1 or 2 or 3 or 4 horsepower. But you're still in the safe zone. You're nowhere near detonation. You're definitely beginning to detonate, but you're not really causing damage at this point. And then you add another degree of timing and you've actually lost 14 to 17 horsepower. And then you add another degree of timing. And if the motor is still running at this point, if you're losing, 5 to 7 horsepower with adding a degree of timing, you're detonating. Like, it's time to start backing it off, or you're going to have problems. I mean, the engine can still run. You might not damage anything, but you add another degree of timing and now you're at negative 20 power lost. Engine detonates, boom, it's all done. Piston goes out the side, you blow a hole through the piston. So I mean, the only difference I've seen is timing, and that's due to increased air coming into the engine. So the more air that gets into the engine, that means there's more for that piston to compress as it's coming up, and so it's igniting that ignition, instead of at top dead center and coming back down, you're igniting a little bit ahead, which is what you want to do, because it takes time to fill that. But when you add that more air getting into the engine, it's actually beginning to combust lower down in the stroke. And so if you back the ignition timing off, that will allow that pressure to reach a higher peak later in the rise of the piston. And then once you finally reach max pressure, you're on the downstroke. But you want to be as close, not super close to top dead center, but you want to be on the downstroke when you reach max pressure, but just after top dead center for peak performance, peak pressures. So timing, I'm backing that off a little bit, but if you don't have a tune yet, you might not even see a difference, because the stock tune was so, what's the word I want to use? Conservative. Just kind of, it's in the ballpark. It was nowhere near max what power it could output, but it was back, 3-4 degrees. So I don't think you should see any issues running without a tune. That being said, at this point I'm doing my own tuning, and the fact that this thing is still running means that I have learned something, but I haven't learned anything serious because I haven't blown it up yet. So hope you guys enjoyed the video. Overall, pretty simple to do. Not really a whole lot that goes into it. I mean, and this GT throttle body, this came off of like an 03 or an 04. But kind of just pay attention to what you're getting. I mean, if you've got a GT Mustang in the junkyard that you're looking at, pulling a throttle body off of, and there's a V6 identical to yours sitting there, grab the throttle body off the V6 and measure it up to the GT. And see, you know, the difference. I mean, you're standing right there. Like, the best thing you can do is educate yourself by looking at the parts and seeing exactly what you're looking at. The 5-liter will not fit. Completely different setup. The throttle body is actually about that long, and with a stock hood, you're going to be running into it. I mean, it could be done. I just don't see a reason to do it. Someday I would like to upgrade this, but again, we're on the road to boost. And this road is, and we're starting to move along here. We're starting to pick up a lot of speed. So here we go.